Somebody I know told me once that a good presentation always has a story. It should have a story. And you all know a good story always starts with something like once upon a time, or even better, long time ago, there was a backend developer living in the server side of things. He was very happy. He used to do things like REST APIs, web services, and things like that. Although he liked many of the languages that the JVM had, sorry, I'm going too fast. He used to work with Groovy. It was the language he liked the most. But let me tell you what happened. He went to the shop. He wanted to buy the latest smartphone available, running Android, of course. He bought the phone. He went home. While he was opening the box, he just realized that he couldn't do what he loved most, do Groovy development on Android. So what happened? He cried. He cried a lot because he couldn't do that. So at that time, he realized that developing Groovy applications on Android was just a nice dream. So, well, he went on with his life just hoping that one day that nice dream will come true. Well, that day came when he was attending the Great Conf. The Great Conf is a Groovy conference taking place every year in Denmark. Well, during the conference, he was attending a talk from a guy coming from a very, very far away country, France. That guy, for example, which is a core Groovy developer, he did a very important announcement during that talk and during that conference. He said that from that moment, all Groovy developers were going to be able to develop Groovy applications on Android. Yes, you can. From that moment, all Groovy developers, we were able to do that. And not only that, he released the first Groovy compatible version for Android, which is called Groovy. Thank you very much, Rick. You did it, man. Well, can't you imagine that backend developer who couldn't do what he loved most? I guess he could have been really happy, you know? Now he could do what he wanted to do. So what he did? He took his mobile and he just was really happy. He went home just to code his first Android application. Everything seemed to be awesome, you know? It was a fantastic opportunity for him. But when he was about to start coding, the light became darkness. Why? Because he realized two very important things that he didn't realize before. First of all, he had no fucking idea of what was involved in Android development. So when he started reading things like PBT, fragments, layouts, UI threads, adapters, and many other concepts, well, he freaked out. He panicked. He didn't know what to do. And even worse, there was almost no documentation about developing Groovy applications on Android, apart from the work of Cedric, apart from his blog and the GitHub account. Fortunately, during the conference, the Great Conference, Cedric not only released the first Groovy version compatible with Android, but also he did the agenda, the application agenda, and this application became the first Groovy application published in the Play Store. So at least there was no empty hands. He could grab the application and see what Cedric did. So the first logical step was to create the first skeleton for the first application. So he read a little bit, he looked into the Android documentations, and he found out that the two principal tools available were Gradle and Android Studio. Okay, so he had to choose. He had to choose either start using Gradle or start using Android Studio, just from the beginning. So he chose the Gradle path. I'm going to tell you later on why he did it. Well, the Gradle path involved to grab some of the Threadrix projects just to see how they were configured. Then everything he needed for his application to start working on it, and then import the application in the Android Studio. Okay. So why Gradle? Well, it wasn't the first time he faced Gradle. As a Groovy developer, he has been using Gradle for a long time. It's a tool. It's a very nice tool. It's mostly written in Groovy, so it's great. It's less verbose than Maven. How many of you have been Java developers? So I guess many of you are still using. How many of you are still using Maven? How many of you are using Gradle? Well, check Gradle. It's a great tool. Well, Gradle is mostly code. It's not XML. So remember when we didn't find anything or a plugin that did something specific in Maven? Well, we were kind of screwed. While in Gradle, if you don't find a specific plugin for your problem, you can code it in the configuration file. And if you're happy enough with the code you have done, you can then move it to the plugin. So that, I think, is great. It's a great difference between Maven and Gradle. One of the things I really love, or I like the most of Gradle, is that I can build different types of projects written in different languages, and I can still use the same tool. Because I don't know you, but to be honest, I hate that for learning a new language, I always have to do two things. First of all, learn the language, and second, learn the reference build tool of that language. I don't want to waste my time. I can just build in any of those languages. We just use the same build tool. So Gradle is great for that. And last but not least, I like not to use an IDE. I have nothing against IDEs. In fact, I recommend you that the first time you face Android development, please take Android Studio, otherwise you will die in the way. Well, once you have just copied some of the Threadrix project, you can just take a look at the configuration file. This is a build.gradle configuration file. It's a very standard one. So what we are seeing here is two plugins which are required in order to make Groovy work with Android. The first one is the standard Android plugin for Gradle, okay? And the second one is the one that we did in order to make Groovy compatible with Android, okay? So basically, you are seeing here where to get the plugins, the repository where the plugins are, and then just applying the plugins to your project. Then there is the configuration of Android, the version of the SDKs you want to target. This particular project only targets one specific version. You can see here that the minimum SDK version is the same one that the target SDK version. Well, you can just play with the version depending on which phones are you targeting. Okay. There are other configurations like the different APKs types that you are going to release. Because this is a proof of concept, I'm only releasing one type. Okay? This is another for just checking errors. But just for starting from scratch, this is good enough. What else? Of course, dependencies. I don't want to start from scratch. I don't want to start coding everything from scratch. So I would like to add some libraries that make my life less miserable. So you can just add repositories where you can find the libraries and then add the libraries. Of course, there are some libraries that you cannot miss because are mandatory. The first one is the Android support, just for supporting the SDK. And the second one, if you want to code with Groovy, is the Groovy library, okay? Can you see? It's still well, this one is beta 3, and I think this project is like 4 months old. I think we are still in beta 4, so I guess in the next months we can have like a release. I'm not sure about that, but as I will tell you during the presentation, I have not found any issue, a specific issue on Groovy, apart from my lack of knowledge about Android. So it's everything about my lack of knowledge, other than that Groovy may have any issue itself. And last, there's the JSON parser. Can you see here the transitive equal false? That's because when you're adding this dependency, it also breaks the whole Groovy library. So because I only want to work with the one which is compatible with Android, I have to put this line here. Okay, so I have configured my project. So the only thing last is just to import it to the Android Studio. Because I have used the Android plugin, usually the Android Studio itself is going to recognize that your Gradle application is an Android application. So you will see how Android Studio highlight your project. So you have just to click, and you will see your project in your Android Studio. Okay, well, this is the structure that you will see in an Android application in Android Studio. You can see the manifest, and you can see that it doesn't matter either it's your Groovy code or your Java code, everything is going to be included in this Java artifact or directory. Okay, this is all Groovy code. Well, the rest, if you are Android developers, the resources, and here the Gradle script, you will see it. Okay, so we have seen the path from Gradle to Android Studio. Of course, if you are used to Android Studio, you can start with Android Studio right away. So Android Studio has a wizard, and you can start Java, standard Java project with that wizard. Then add the center plugin if you want to develop with Groovy. And finally, well, keep working in Android Studio or in the console or in any editor that you may want. Okay, so this is one of the first screens of the wizard. So it basically tells you the name of your application, the package, where you are going to put all your classes, and the project location. And if you just click and go on with the wizard, you will have like a standard Java Gradle application, but already in Android Studio. Okay? Well, it's not very grand, just getting here. So this backend developer swore that he will never ever repeat the same mistakes and the same path because, you know, just configuring the plugins, configuring the dependencies, configuring how it should work is kind of error prone. So he thought that there should be something just to help him in the way. So he had a wish list. He created this wish list to see if some tool will do that for him. So the wish list was basically having a basic working Groovy skeleton, some basic helpful dependencies like, I don't know, like a library for REST API or in dependency injection or something like that. Something that when he really wanted to start a new project on Android using Groovy, he didn't have to start a skeleton from scratch, but started just coding. Of course, add documentation, and if you don't know what ASCII Doctor is, I will recommend you to check it out, okay? So, this is one of the tweets Ivan sent me yesterday, because we're going to start a project without documentation. So, ASCII Doctor is, I would say, is the best tool out there for documenting your application. So check it out. And basically, just don't start from scratch. Something that once you have just created the project, you can just click on the Android Studio and play your application. Okay, so he looked for some tool to do that for him, and he found LazyBones. LazyBones is a Groovy project led by Peter Leibrook, who's a London guy. Well, Peter, well, he always tells the story. We are developers, right? We are lazy by nature. So the less we can do, the better. So he came out with this project. It's basically, if you knew what mapping archetypes are, this is pretty similar. But I would say it's easier. You can check the project out in the GitHub account of Peter. I will publish the slides later on GitHub probably, so you can check them later. Okay, so with LazyBones, that backend developer could fulfill the business. So basic working Groovy skeleton done, basic dependencies done, ASCII doctor, of course, done. And well, you can add whatever you want, so you cannot have to do it from scratch. Okay? So once he finally had the skeleton of the project, he could start doing what he wanted to do from the first time, which was coding with Groovy. It wasn't easy. In fact, the first lines of code look very similar to Java. So I don't know if you can see it very well back there, but the fact is that it's just a class extending an array adapter, and well, there is some code that looks like Java, but there are some details. Okay, so I'm going to go through all those details. First of all, if you have been developing with Android, if you extend array adapter, you have to create a constructor. And that is boilerplate code, and as we will see during the presentation, one of the things we do best is to get rid of the boilerplate code. So in the language, by default, we have some what we call transformations. Are basically annotations that get rid or generate code during compilation time, not during the runtime of compilation time. So the first one, inherit constructors, change it from writing constructor that you should be writing because you are just extending a specific class. Also, you get rid of the accessors. So let's say you have a domain class like this one, and you want to start like generating the getters and the setters and even the toString. I have just bring it here, but it's not necessary. There is another transformation that takes care of that for you. So, what that involves? Well, that means that you can access those fields like if you were accessing directly to the field, but that doesn't mean that you are accessing to that field. That text with the equals mean that during runtime you are actually doing what text field, set text, and then the parameter is this one. So you are not accessing the field, but accessing the accessor, the setter in this case. Okay, the same thing here. We will see later on while we're doing the presentation more examples of immutable, which is an annotation that creates some code for you that makes well, not impossible, but really tough to mutate your classes. So if you are ready for functional programming, I would recommend that you use it. Of course, you don't have to create many constructors just to create your classes. You can use the default map constructor of Groovy. So if you want to set your fields, you can just create a map inside the constructor and start assigning or just putting values to that particular field. Okay. There is another way of doing this. It's just a map. And as you can see here, this is like a coercion. You're saying that this maps is actually a given class. And even if you are worried about dynamic typing, as we will see later on, using compiler static, that is statically compiled for you. Okay, Groovy collections, of course. one of the things shines in Groovy is the collections. In Java it's really a problem because you have to, when you are looping through a collection, there are some local variables that you have to fulfill. With Groovy we have this filter and mapping, which is how I find and collect. And for a given collection, you can filter some of the items, maybe take some of them, and then transform the values of the collection. So there's a very fluent mapping for that. Yes, I think. Yeah, you can see here, I have the compiler static. So everything you see here is statically compiled during compilation time, not runtime. Okay. One of the things I first noticed when I started programming with Java and Android is that there were so many inner classes. You have to create so many inner classes. This is an example of my first attempt to use Groovy and Android. I started writing just plain Java code. So for a timer status, you have to create a timer status inner class, which has a run method, and then inside you have to write the code, the value of the code. So that will turn into this, okay? What we have here, because all functional interfaces, let me go back because I have to explain something. Every time that in Groovy you have a functional interface, which means a functional interface is an interface that only has one method. So every time you have an inner class that you have to implement and is a functional interface, you can use a class. This is not a very good example because what I'm doing here is that turning this method into a class. Okay? You can see this ampersand here. What I'm saying is that this function, this method here, is going to turn into a function, and I'm going to pass that function to this method. So in compilation time, the compiler says, okay, what do we need here in the schedule? A timer task. This could be a timer task. Yes, then it's okay. And again, this is not magic. If you put compiler static, it will check it out if it's really a timer task or not. So, for example, here we have another functional behavior. You have another function with 2 parameters, and you require here an interceptor. So if you just do a partial application of the method and only has one, well, this means that basically you have done a partial application of the method and it turns the method into one method with one parameter. So as we will see here, this functional interface, one interface with just one method, can be turned into a function and passed to that method. This example is better, you will understand better because it's a little tricky. This example is taken from the retrofit library. It's a very well-known library for doing REST APIs clients in Android. The problem is that it is still Java in the way that it still needs inner classes. So for example, again, this is a functional interface with just one method. And once you have just created the instance, you just pass it to the method, okay? So how it looks like in Groovy, like this. Every functional interface will be converted to a cluster. So this is the body of that method, okay? So you save a lot of code, okay? And again, you can do static typing for that. So, well, there's traits because Frederick not released like an older version of Groovy, but the latest version of Groovy. If you want to start developing Groovy applications on Android, you will have the latest version of Groovy. And one of the features are traits. Traits are great for sharing behavior. So let's say I have like a behavior, and I want just to have a progress dialog, typical spinner that says that the application is waiting for something to happen. I want to just encapsulate that behavior. So I can use straight. Why? Because in Android, as far as I know, there are, or sometimes you have to extend a given class. So let's say, for example, you have an activity and a list activity. And because you have to extend from activity or to list activity, you can make those classes extend the same class. But you can implement a trait. So let's see how it looks. Can you see here that I have two activities in Android? One of them is extending activity and the other one is extending list activity. But both of them can have that behavior. So in compilation time, that code is included in both classes, so that you can use that behavior in both of them. Okay, it's very useful. And yeah, I think you have may noticed the red lines. That is not because it doesn't compile. It does compile, but it's because Android Studio doesn't recognize the traits yet. Okay, I guess in IntelliJ, the normal version, it does, but the Android Studio doesn't. Okay. There are many other ASTs by default in the Groovy language that can generate code in compilation time for you. Those are just some of them, not all of them, but some of them, and are very, very helpful. We have seen immutable, for example. We have seen traits. Sortable, for example, for creating different comparators. If you have a list of the main classes and you want to sort them by different restrictions or different, I don't know, different ideas, you can use sortable. What else? I don't know, there are many of them. For example, autoclone, if you want to get rid of the code needed for doing clonable instances, you can use autoclone. There's this equals and hash code. If you don't want to create your own equals and hash code and the string, which are error prone most of the time, you can use this annotation and it will create the code for you. Okay? As I said, there are still a few more, so check them out. Because you can create your own ASPs. I found this library, which is written in Groovy by this guy, which is a Spanish guy. I don't know, is Jorge in the room? No? I don't remember him, so I don't know how he looks like. So I only have this photo from his GitHub account. Well, what he did was more ASC transformations because he had to work with Android and he found some boilerplate code and he wanted to get rid of that. So he created this library. I'm going through the library and show you what he did. First of all, he created injected views, which is a very nice feature because most of the time when you have to get the instance of a given view, you have to use the find by UID, then cast the instance, the right type, and then use it, okay? So when using this library, you no longer have to use find view by ID because you have just written the type and the instance, and the ASC transformation will do the rest of the code for you. So you are saving code and not longer to be worried about casting. So basically, what do we have here? We have injected the view with the right ID of the given widget, and then you only have to use this line in order to your activity to take care of the rest. So, for example, the rest of the activity you can just go and ask for the given widget, and because it's already casted, so it knows what type it is, you can call the right methods. Okay? And again, this always knows what type it is. There are another AST transformations such as on background and UV thread, because most of the time when you are a beginner, you don't know how to program your things, and suddenly everything blows up and you don't know why. And most of the time because you try to get some results from online and you didn't realize that you were doing that in the UI thread. So you only have to take care of your code with this annotation. So if you want to go online for getting a user list, you just annotate the method with a background. And if you want to call something that is running on the UI, you only have to annotate it with your own UV thread. And the transformation will take over the rest of the code. So no longer you have to do that by hand, but the transformation will do. Again, when you are just triggering an event and you want to do something when a button has been clicked, the same thing. You have to click, and you only have to take care of the logic of your business logic. So when this button has been clicked, you are going to call in the background and say the quote, and maybe notify the message. Probably this method has been annotated with UV thread. Okay? So there is a lot of boilerplate code that the transformation will get rid of. There is another project. I think it's still like something as a proof of concept, but it's nice to see. This guy, well, his name is not Funkel, it's just a plain German guy. Well, he wrote these drawing tools, which is an attempt to create widgets with the code. He created a DSL in order not to use the XML, but using the code for creating your widgets. So this is an example. If you wanted to create a text view, you can create the builder, which enables the DSL. And inside you can create a text view with a given color, for example. I have there the GitHub account and the project, and you can check it out. As I told you, it's still in beta. He's working on it, but this is still something that is just a proof of concept. This is another example. As you can see here, you want to create a view with a relative layout, with all the properties that you normally would put in your XML, and then put a text view with the same properties. Okay? So if you are a programmer and you don't want to be dealing with XML and with the view, you can do it your own with your code. Okay? I think this is one question that everybody's asking me. How about performance? And well, I have different answers. The first one was that many times you know that the problem is not the language itself, okay? But the programming. But anyway, we have compiler static, okay? I will talk a little bit more about compiler static. Compiler static, what it does? It optimizes the byte code, okay? So it takes your code, your Groovy code, and tries to figure out the types and also the byte code if it can optimize it before in the case of JDK, before the JVM optimizes. So it does the work after before. Yes, sorry, I haven't been working with Android for a long time, so I still don't have benchmark on Android, but I will tell you something later on about it. In the JDK, of course, we've been doing very well because the JVM has this bulk dynamic, and not only is really close to Java, but in some benchmarks, it's really faster than normal Java code. Anyway, on Android, it's advisable to use it anytime you can, because I'm not an Android developer, but I've been talking to Android developers, and always told me that it's very, very important the performance. So if it's very, very important the performance, then use it. Okay, but don't freak out. I mean, it's more important that your code is really, really, really short than it's. I mean, shorter code performs better than 2,000 lines of code. So it's not only about the performance. Okay. Anyway, I came across this article from the New York Times, and it turns out that they are using Groovy. I really recommend you this article because they were talking that they needed like a very low latency. So everybody was then wondering why Groovy then? Well, it turns out that they use Groovy because of the script. Because Groovy was more descriptive than Java, and because they couldn't use Java 8 for Android. You know, this issue between two companies, big companies. So they use Groovy and RX Java. So they are building really, really fast applications. They need those applications to perform really, really well. And they are using Groovy. So maybe Groovy doesn't perform that bad. Don't you think? So what next? Well, there are many things to do. There are still many things to do in Groovy. We have just started, so we still don't know many things. So, for example, I can tell you that the Drip is working on the Android. I think there are some issues with Groovy in order to work with Android Wear. I think it has to do with the connection between the devices. But it's very, very close to make it work. So I would recommend you want to follow what is Groovy doing on Android, to follow that link. And who knows, maybe in the future there will be many Groovy developers doing Android applications. Thank you. There are still some minutes to do some questions in Spanish or English. That's allowed.
Bueno, no hago castellano por si acaso. Soy un técnico porque de verdad que Groovy no soy un Groovy. Tengo entendido que un Groovy necesitas una dependencia de tus proyectos que es el runtime de Groovy.
Sí. Sí.
Ese runtime de Groovy viene a ser unos 2 megabytes o algo así en un pack.
Sí, sí.
Cuando tú utilizas un file static, cuando creas el proyecto de Android, necesitas incluir ese hack, un megabyte de hack.
¿El de compile static?
Incluso con compile static. O hay una forma de no tener que incluir esa versión de la gráfica que
¿La de Groovy?
Sí.
No. No, porque, o sea, aun compilándolo estáticamente hay la forma en la que trabaja el lenguaje. Tiene que hacer ciertas inyecciones, entonces necesitas la
Has hablado de testing. ¿Has probado el testing con Android?
Tengo que reconocer que no he probado el testing porque yo estoy empezando también a desarrollar en Android y me preocupaba más saber qué se podía hacer con Groovy. Entonces, coger código Java, mirar cómo funcionaba, ver cómo mejorarlo con Groovy y todavía no me he puesto con el tema de testing. El tema ahí en
¿Qué es lo que echas en falta especialmente desarrollar Groovy?
Sobre todo más gente que esté desarrollando. Acabamos de empezar, os he enseñado algunas bibliotecas que están haciendo la gente y creo que no solo para los desarrolladores Groovy, que nosotros ya conocemos esas historias, sino para los desarrolladores Java puede ser interesante. Pero supongo que cuanto más gente se una, más bibliotecas hay. ¿Había otra cosa?
Desarrollamos en Groovy, la parte de servidor, y desarrollo la parte de Android. Tengo bastante impresión por la parte de Groovy, de que viniese esta charla, la explicase. Mi pregunta siempre miedo es, ¿crees que está listo para producción, para aplicaciones de clientes de verdad que no dan mantenimiento.
A ver, yo te diría que si el vídeo está en usar, lo pone en producción. En el artículo lo pone, que empieza diciendo que necesitan una latencia increíblemente baja, ¿vale? Según la cual, cualquier tecnología que no cumpliera esos requisitos sería desechada automáticamente. Me parece un requisito de lo más brutal. Entonces, yo creo que si ellos lo consideran.
Pero no conocía la referencia de New York Times, yo creo que es una buena referencia. ¿Y qué tipo de bugs crees que podrían encontrar al esta modalidad en venta? ¿De qué tipo? O sea, ¿serían cosas de masa SP?
Por ejemplo, yo todo lo que estaba haciendo, los problemas que me encontraba han sido por mi propio desconocimiento de la plataforma. Entonces, cuando tenía un error, realmente iba a estar con el flow y era un problema de o de cómo programar, pero no era un problema del lenguaje. Por ejemplo, sí te puedo decir que con el Android Web, sí que Federico estaba teniendo problemas. Sí que estaba teniendo problemas con ciertas partes de cómo se comunicaban los dispositivos. Pero en lo que es Android en cuanto a móvil, yo todavía no he encontrado ningún problema de lenguaje comprensivo. ¿Una más? Bueno, pues muchas gracias.